Hi everyone, the purpose of this video is to go over one of the problems from Check for Understanding number 1 in the energetics unit. I got some requests to talk about it, so let's do it. All right, when 25 cubic centimeters of 100 molar NaOH is mixed with 25 cubic centimeters of 0.1 molar HCl at the same temperature, a rise in temperature is recorded. That's not surprising. When I go back to my Q equals MC situations or options, this is a reaction. I have two reagents, and it's specifically an acid-base reaction with two solutions, which is called neutralization. And we've already learned neutralization or exothermic. It's a chemical change, so if temperature is going up, exothermic. All right. So far, so good. So I always recommend drawing for myself what's happening so that I hold in my mind the chemistry that's happening. I'm not just thinking about it like a math problem. So if 25 cubic centimeters of NaOH at the concentration 0.1 mole decimeter cubed. I also put in 25 cubic centimeters HCl, I believe, at a 0.1 molar concentration, 0.1 mole decimeter cubed. Awesome. That gives me a total volume of 50 cubic centimeters. All right, I'm finding molar enthalpy, kilojoules per mole. So I need to set up an equation for finding kilojoules over finding moles. Cool. Let's try to find the kilojoules, the enthalpy released. I'm going to use my old standby, Q equals mc delta T. Mass, of course, is 50. This is the one situation where we add the two masses. So 50 cubic centimeters. C, 4.18 joules per gram degree Kelvin. Let me just make this a little bit smaller so that I have space to work here. Thank you for bearing with me. I'm going to move this here, move these over here. All right. Back at it, joules per gram Kelvin, and the temperature rise was just delta T. They don't tell us what it is. Now, that would give me an answer in joules, so this then needs to get divided by 1,000. All right, awesome. Now, moles. Moles, remember, molar enthalpy varies depending on what kind of thing you're looking at. In this case, we're looking at neutralization, so molar enthalpy is per moles of water produced. That's different than combustion, for example, where it's per moles of reactant. You need to pay attention to the type of reaction you're doing. All right, how do I figure out the moles of water produced? Well, I have two reactants. I need to find out which was limiting and my theoretical yield of water. Cool. Okay, so I have HCl here. I'm going to figure out how much water HCl would make if all of it reacted. 25 times 25 cubic centimeters times 1,000 cubic centimeters, 1 decimeter cubed. I have a sense I'm going to need to move this over. Let's make my drawing a little smaller. Move this up. Okay. Cool. 1 decimeter cubed, 0.1 mole HCl. We should probably write out our reaction. I was just kind of assuming we had this in our head, but let's write out the reaction. Double replacement, so Na in the Cl, H in the OH to form water. Great, all coefficients of 1 because everything is balanced if you count that out. All right, 1 mole HCl, 1 mole H2O. This math is pretty straightforward. Notice this is a no calculator problem. So I have 25 times 0.1 divided by 1,000. That's 2.5 divided by 1,000. And I'm just looking at my answers here to see which one will make the most sense. I know it's going to be something like 0.123, 0025. Yep. Okay. All right. I know that this 0.0025, I'm not seeing it in one of the answers, so I'm going to need to take a look carefully at the answers here in just a moment. But let's check NaOH. I'm suspecting I see the same numbers, so I'm actually realizing neither reagent is limiting. They both react exactly equally. Times 1 decimeter cubed NaOH. Trying to figure out theoretical yields of water. NaOH, 1 mole H2O. I know I'm working through this really quickly. That's because I'm assuming that you're feeling good on the stoichiometry unit. If you have questions on stoichiometry, you need to be emailing me, coming to office hours, getting those cleared up as soon as you can. Wow, I did it a little too quickly. We did not even put in our 0.1 mole for the molarity. All right, so again, 25 times 0.1 divided by 1,000. So I see that no matter if HCl or NaOH reacts completely, they make the same amount of water, moles of H2O. All right, so let's go ahead and figure out the only kind of trick left to doing this is to figure out what's going on with these answers. How can we match these answers up with what we came up with? That's kind of the IB trick part to this problem. So let's take a close look at these answers. Trying to give us some space to work here. So I've now found the kilojoules of energy from the reaction. I've also found the moles of water produced, which is what we use for molar enthalpy for neutralization reactions. And now I just need to deal with which math is correct. All right, so I'm taking a look at my equations. I see negative signs. That's because exothermic, all of them are negative. Great. And I see in the top they did the Q equals MC delta T math. Can immediately cross these out because they use 25 cubic centimeters for mass. We know with neutralization that that's not correct. So now I have two options, and now I have to figure out, all right, which of my options is going to get me to the correct number here? Well, I can pretty easily see it's the 25 times 0.1, which we expressed when we did our stoichiometry as 0.0025. So that is indeed our answer, D. And this is, so you're looking for the numbers that match up with the numbers that you would plug in. So kind of a weird problem because you're not trying to get to one final answer, but just trying to set it up correctly, recognizing which mass you should be using, recognizing the yield of water, and of course 4.18 being specific heat, etc. All right, hope that helped. Have a good day. Bye.